Assalamualaikum my dear students. I hope all of you are fine and doing well. So in our today's video, we will basically discuss about the density of an ideal gas. So one when we have to talk about the density, so density is basically is equal to mass per unit volume. That how much the volume has been covered by the given gas according to its mass, or it is known as the ratio of mass to volume. It is known as basically density. So here we will discuss about the density of an ideal gas. For this purpose, we have to calculate or we have to derivate this equation, which is D is equal to P into M over RT, where R is the general gas constant and T is basically temperature, P is the pressure, and M is the mass or molar mass, and the D is the density. Now, how we can calculate this equation? For this purpose, we have to use the general gas value or the general gas equation, which is equal to PV equal to nRT. So here we have to find or derivate the density of ideal gas from this equation. For this purpose, for this derivation, we have to just put up some values in this equation. Let's have a look on this. Basically, for calculating the density of an ideal gas, we have to substitute the number of moles. When we substitute the number of moles, then we can be able to calculate the density from it. So, how we can substitute it? First of all, we know the values or the number of moles is equal to mass in gram divided by molar mass. And the general gas equation we have PV is equal to nRT. So here we can put the value of n, then the equation will be PV is equal to m over m and r into T. So here we have put the value of number of moles. After that, we just know that or we have to rearrange this. We gain by rearranging this volume and mass, we gain Pm is equal to m over V and R into T. So we have just swipe up volume and molar mass. On the other hand, we know that density is equal to mass per unit volume. So on the ratio of mass per unit volume, we can put the density. So the equation will becomes Pm is equal to D and R into T. Then we will rearrange this equation. We gain D is equal to Pm over R into T. So this is the simple density of the gases. Hence, the density of an ideal gas here is directly proportional to the molar mass. It is directly proportional to the pressure, and density is inversely proportional to the temperature. So if we have greater pressure, then the density will be greater because molecules will come close to each other and they will become dense. But on the other hand, when we increase the temperature, in turn the density will be decreases. So all these values are interrelated to each other. If we can calculate the relative molar mass by using the value of pressure, temperature, and density of any gas. So let's have a look on the example number 1 for this purpose. Here we have an example in which we have a gas that is having density is 1.70 gram per liter at standard temperature and pressure. And standard temperature pressure means here the standard temperature will be 273.16 Kelvin and the standard pressure is almost 1 atm. What is the molar mass of the gas? So we have to calculate the main molar mass of this gas and what gas if it gas is a diatomic. So first of all we have to identify which one gas is this. For this calculation we will use the equation which is Pm is equal to dRT. So Pm is equal to dRT. Here we have to calculate this molar mass. So we have the values pressure in 1 atm, mass we have to calculate, the density is 1.70 that is given, and the general gas constant we will use it over there, it is 0.0821 atmospheric liter per mole per Kelvin, and the temperature we use it is 273 Kelvin. By putting up the values, here we have 1 atmospheric pressure, the molar mass is this, and the density we have 1.70 gram per liter, and the value of R we have this, and the temperature is this. By calculating, we find the molar mass of this gas is almost 38.10 gram per mole. Now, if the molar mass of the gas is 38.10 gram per mole, from this we have to calculate which one gas is this. As he told, the gas is a diatomic. So, what will be the possible formula for the gas? So, it is basically a halogen gas. As the first one halogen we have, it is fluorine F2. Its diatomic form is 19. Multiply by 2, then we will gain 38 gram per mole. So this gas is basically fluorine. So this is all about today's lecture, that we can calculate the molar mass of any gas by applying the different conditions or the different units over it. I hope you guys understand, and if you have any queries you may ask me about that in the comment section. And the next topic that we will discuss, it is the effect of pressure and temperature on density. If we are going to change the pressure and temperature, then what is going to be happen with the density of the gas? For that time, you guys have a good day and Allah Hafiz.